Hello and welcome back to Merge Ready. Today we're going to have a look at the news articles surrounding the AWS outage on October the 20th. You will remember this from last week when AWS went down and it affected millions of services across the world. We'll talk about why this is a problem, if that wasn't obvious, what steps should be taken across organizations to try and avoid this in the future, and the real problems and difficulty with actually really planning for an outage such as this in today's environment. We'll also look at Amazon's reaction and apology and just go through what happened generally. So first of all, we will head on over to the register here, and we can see here the perfect AWS storm has blown over, but the climate is only getting worse. So this is an opinion piece on the register talking about the general fallout from that event last week and some ideas around it. Well, the first point here that I thought was interesting is that it was predicted by an ex-Amazonian based on their perception that key engineering talent had been fleeing the company for years, which is really, really interesting to see that someone had predicted this. Now, would you have to be that kind of on the ground part of the company to predict something like that? I don't think so. I think people outside of the company had predicted issues like this happening many times in the past. Removing irreplaceable wisdom built from knowledge and experience. This is the resilient part of staffing and engineering, which isn't necessarily always highlighted, is independent silos of knowledge. So one person knows how everything works and doesn't share that knowledge across teams, doesn't document it well, and generally knowing all of the components to a system, which at AWS is going to be so incredibly vast. So how do you stop this happening again? There was no answer to that from AWS in their apology, which we will look at in a minute. How do we stop this happening? How do you stop this happening? AWS cannot stop this from happening. There will be service outages. It's the nature of the systems they have in place, especially with the complexity and the just sheer amount of services, data centers, employees. It's built by people, right? And human error is a real thing. How do you stop this happening again? Well, building safeguards for specific chains of events. It's easy to say that it's obvious how to fix this by removing dependencies, but that in itself is an incredibly difficult task. None of this answers the basic criticism that AWS itself is too complex to analyze. Yes, absolutely, AWS is ridiculously hard to analyze. For such systems of failure, at least with resources and tools it has on hand right now. Exactly the same can be said of the systematic cybersecurity failings that power the rolling thunder of ransomware and the other eviscerating attacks. I mean, that's just so incredibly true. And you should note here, when we're talking about AWS itself being too complex to analyze, that doesn't mean you as someone using AWS is too complex to analyze. It's the behind the scenes, the infrastructure and dependencies for AWS itself that is too complex to analyze. However, it would also be true to say that your own AWS accounts may be too complex to analyze if you are utilizing a significant amount of their services. There are so many ways to add resilience to this picture. Now, there are ways to add resilience to this picture, of course. I think this particular paragraph is talking about the Internet of Things, IoT devices. Edge services can keep cloud IoT devices going during a central outage, as long as those edge services are true edge services without dependencies on anything in the central data center. Even better, enough local compute built into the devices that will bring resilience even in the case of whatever godforsaken subscription revenue model underlying the initial offering can't keep the parent company alive. So yes, local compute is something that if your device has had enough of it, it can continue to do what it needs to in the event of an emergency. It may not perform at its best, it may not produce the quality of service that you might expect, but it may prevent a complete outage. And this might also go for company infrastructure as well, having a hybrid solution where you have a local data center within your office or in a local data center to you that is used as a backup in the event of a cloud failure. This is much more complex and a lot harder to do, but it is something many companies operate in, if not migrating away from the cloud completely. Yes, so when a correction does come, it is going to be a biggie. What this means is when a correction does come, it's going to be a biggie. If our systems break as often and obviously as they do in today's climate, what would they do if things got stickier? Our international financial and commercial systems got given a proper nudge by those who do not have our best interests at heart. And the closing paragraphs in the register: fortunately, resilience can be improved from the bottom up rather than waiting for top down to happen. As responsible individuals within departments at board level or as industry groups, what ifs can be wargamed. You know what a power outage means and what level of power pack is needed, what UPS generator is worth having. If AWS was to go away for weeks instead of hours, what would it look like? What would the redundancy look like? Can you afford an experiment or two? Or can you afford not to? So this is key. People are going to have to be experimenting with disaster recovery, rehearsals. We are going to touch upon it again later, but multi-cloud is likely to become even more prominent given last week's outage. If you've never had this sort of conversation about any or all of your core technologies and services, then you're part of the problem. This is something everyone should be doing, is having the discussion around your core technologies and services, how resilient they are, how reliant they are onto a single cloud provider or a single service, just looking down the full dependency chain and ensuring that any single points of failure are identified and you mitigate that, or at least highlight the risk and do a business impact analysis to make sure that it is worth that single point of failure, worth having that risk. Amazon apologizes. Let's look at the Amazon apology. So AWS has apologized to customers impacted by Monday's massive outage after it knocked out some of the world's largest platforms. So are we seeing a scale of apology due for the scale of outage that we had and the scale of customers impacted? Let's have a look. We apologize for the impact this event caused our customers, the company said. We know how critical our services are to our customers, their applications and end users, and their businesses. We know this event impacted many customers in significant ways. While many platforms such as the online games Roblox and Fortnite were back up and running within a few hours of the outages, some services experienced prolonged downtime, which we always knew was going to happen, including Lloyds Bank, yada yada yada. In its lengthy summary of Monday's outage, Amazon said it came down to an issue in US East 1. As we're aware, the main region for AWS, the biggest region for AWS, where many other regions are actually dependent on US East 1 services. Critical processes in the region's database, which stores and manages the DNS records allowing website URLs to be understood by computers, effectively fell out of sync. According to Amazon, this triggered a latent race condition, or in other words, unearthed a dormant bug that could occur in an unlikely sequence of events. And you've got to remember that with the sheer amount of services, the sheer amount of requests and databases and data, unlikely sequences of events happen all of the time. The delay in one process, which Amazon said occurred in the early hours of Monday morning, had a knock-on effect which caused its systems to stop working properly. You don't say. Much of this process is automated, meaning it's done without human involvement. Automate all the things. But automate them well and look for edge cases. Dr. Janardi Ali, a software engineer and fellow of the Institute of Engineering and Technology, told the BBC faulty automation. Faulty automation had been the core of Amazon's problems. The specific technical reason is a faulty automation broke the internal address book systems in that region rely upon, so they couldn't find one of the other key systems. Yes, DNS broke. Like others, Dr. Ali believes it highlights the need for companies to be more resilient and diversify their cloud service providers so they can fail over to other data centers and providers when one isn't available. Yes. Multi-cloud, hybrid cloud, having on-prem combined with AWS. You've got all of the systems you need to be able to create links between your database and AWS now. All the direct links are there. You are able to have high-speed connections to your database from AWS if you are a large enough company. However, if you're a small startup, small SaaS startup, it's really less likely that you will be able to afford it. Should this be an inherent service within AWS and Azure where making connections and replicants between the two clouds is built in, where you're able to fail over from one to the other with built-in services? There is some of that you can create. It's unlikely that a cloud provider is going to offer a very easy integration into other competing cloud providers. AWS outage. Are we relying too much on US big tech? This is obviously a BBC News article in the UK talking about how we rely on US AWS rather than having our own European data centers. Yes, obviously the outage had different impacts on different people. Losing a built-up streak on Duolingo, probably less important than the vital banking, governments, and all that kind of stuff that broke too. Here we have a graph of the top 10 data center locations for AWS. North Virginia, US East 1 at the top there. Amazon has embedded itself within the very fabric of cloud computing, the infrastructure that underpins the delivery of IT systems, which are so much a part of all of our lives. Let's have a look here. So, because even a service itself is not hosted on one of these two giants or the UK's third largest provider, Google, critical things it relies upon might still be. So I've worked at many companies when procuring a new third-party tool into a stack requires you to really deep dive the dependencies of that particular application. For example, if you were bringing in a new DNS provider for your application and that provider relied on AWS and you relied on Azure and AWS as multi-cloud, you've then defeated the purpose of having Amazon and Azure because your dependency is solely reliant on AWS. So you would have to investigate that particular supplier, the vendor, the tool, to make sure that it's also resilient. And then it gets complex because what are they reliant on that also are reliant on AWS or Google or Azure? And that chain can be infinitely long and it can have circular dependencies. It is crazy. It is such a pigeonhole to go down when you start looking into the resilience of tools that you're getting and using, especially with all these third-party tools that everyone uses. Again, you can only go so far, you can only go so deep into that chain, and do your best to make sure that you're resilient in all areas of your application. It means the company doesn't have to pay the hefty cost. Okay, yeah, so the economies of scale here. If relying on a small number of US firms has its risks, why do so many companies do it? Because it's cheap. The answers, experts say, is that inking contracts with household names such as Amazon, Microsoft, and Google also has its upsides. This is true. Yes, pay as well, but also, a lot of people have preferred supplier lists who are, they have to have certain credentials, certain certifications, certain regulatory standards to be adhered to. And AWS, Google, and Azure are going to have that, being such massive companies. Therefore, they are very, very easy to get sign off to use. The hefty cost of running its own servers can leverage the power of so-called hyperscalers. So yes, if you are using cloud compute properly, it can be cheaper than running your own data center. I say can be. I know a lot of you might be shaking your heads there, but if you don't understand the concept of elastic pricing, making sure you're auto-scaling, make sure you're really optimizing the cost of your infrastructure, then it can be cheaper to self-host your own data center, running your own hypervisors. However, that again can get quite expensive. You've got to look at the hardware, the power, you've got to look at the cooling, you've got to look at the support that you need to manage that infrastructure and look after it. You've got to look at the cost of refreshing your hardware every 3 to 5 years, and then the cost of getting in multiple internet lines for redundancy. It's much easier to use a cloud provider. That is probably the key to it. It's incredibly easy to start an AWS account and provision a server within seconds. You could have the comparison of a data center running in minutes. The cloud is incredibly flexible, and that is why so many people use it. Yeah, the explosion of enterprise data now stored within a single provider like AWS makes the eventual cost of migrating to different vendors prohibitively high. Prohibitively. There we go. I can say prohibitively, I think. Yeah, it's expensive to move data from one place to another. It's expensive to re-architect your infrastructure using another cloud provider's architecture. It's all very well having everything in Terraform and that Terraform being multi-cloud, but the Terraform that you have for your specific cloud provider is using their provider, and it's all very, very specific to that cloud provider. And you can't just switch from AWS to Azure in Terraform alone. So there is a massive, massive cost to migrating between clouds if you are well established within that cloud, and if you need to move hefty amounts, terabytes, petabytes of data between those clouds as well. And the loss of service that you might have during that migration, the planning and the executing of that, it's hundreds of millions of pounds, if not billions of pounds, for some really large organizations. This is the risk of the over-reliance on two dominant cloud providers, an outage most of us will have felt in some way. This is it. We're going to have this. We have 2, maybe 3 big cloud providers, which all of the internet, 90% of the internet probably runs on. If we only have the 3, then what are the chances that one of those 3 go down and therefore a significant chunk of the internet is impacted? Unless we start moving to hybrid cloud. So moving over to multi-cloud, hybrid cloud, some on-prem, making sure you're using edge services, anything like that is key. You need to have these conversations with your stakeholders, with whomever you need to have this conversation with, saying, what if this doesn't work? And now what you'll hear is, well, the chances of that happening are, and yes, it's hard to quantify what the chances of something like that happening is, but it's easy to calculate the cost to the company should your services go down for an extended period of time due to an outage like this. You need to explore multi-cloud options. You need to explore how you can mitigate the risk of all of these dependencies from causing your systems to be going down like this. You need to have these conversations specifically to avoid being on lists on the BBC just like this. You can do it. You can experiment. You can spin up and test an Azure account, replicate a database from AWS over to Azure, and just look at the cost of that and versus the cost of your systems going down. And the final point in this article here is that the UK government should take the lead in mandating data resilience standards across key industries, including policy frameworks that require the use of 2 or more distinct cloud providers and promote continuous data replication. So, is this a conversation we're going to see from the regulatory industry where we must be using multi-cloud, we must be replicating data? And what will that regulation look like? Will we have to have hot standbys for certain industries? Will we have to have just data replicated? Will we just have to have backups in a different region? Because remember here, we're not talking about data loss being the issue, we're talking about resiliency. Therefore, discussions where we're talking about regulating the multi-cloud provisioning, we're probably talking about having a regulated, defined time to recover services into a different cloud for key organizations, such as the government, such as financial institutions. This is going to be interesting if these discussions do take place and if this is something that comes out of it. Thank you very much for listening to me ramble. Please subscribe if you found this useful. Keep an eye out for my future videos where I'll be discussing AI in DevOps and the future that we can expect. And we'll also be doing a tutorial on GitLab CI/CD pipelines and some of the more advanced features it provides. Until next time, stay merge ready.